Hey y'all, welcome back. Today we're going to go ahead and talk about the Test 2 review. This review is a little long, a little bit longer than the actual test actually, but I think this review is going to help you prepare for that exam. So much, but they're doable, and I think we can get it done within a couple of minutes per problem. So let's take a look at number 1. It says find the GCF of each set of monomials. Remember, monomials are dealing with one term. So we have a set of monomials, meaning that we have one term here and a one term here. They both don't have any variables. They're just actual numbers. So we can go ahead and try to figure out, okay, well, what is the highest number that goes into 60 and 45 at the same time? So if you're having troubles figuring that out, if you can't just see it, then my recommendation to you is to just draw that factor tree. So write a 60 and a 45 over here, and then you're going to do a caret sign for both of them, okay? And then now you're going to think, okay, what two numbers are going to multiply together that gives me 60? And I'm thinking 15 and 4, okay? 15 times 4 is going to give me 60. Now I need to make sure that I can break down these numbers until I'm left with just prime numbers. So looking at number 4, 4 isn't a prime number because I can say 2 times 2 is going to give me 4, right? Can I break down the 2? No, because it's a prime number. So these are prime numbers. I can't break them down anymore. So let's just take a look and move into 15. So 15, well, give me two numbers that multiply together to give me 15. Well, that's going to be 3 and 5. 3 and 5 are prime numbers, so I can't break them down anymore, so I am done in this case. Now I'm going to go ahead and look at 15. Well, or sorry, not 15, 45. Two numbers. Well, I'm thinking 15 and 3 because 15 times 3 is 45, and 3 is a prime number, so I'm not going to break that down. 15 in this case is not prime, it's a composite number, so I'm going to go ahead and multiply that by 3 and 5. Exactly what we have here, right? When we break down the 15, we want to make sure that we have something very, very, exact. Okay, so now what I'm going to do is I'm going to go ahead and write my prime factors of 60 and my prime factors of 45. So my prime factors of 60, again, I can only list out the numbers that are prime. So 3, 5, 2, and 2, exactly what we have here. And then I have 3, 5, and just the 3, okay? Now, what I'm going to do is I'm going to find the greatest common factor, and remember when we have something in common, they're going to go in this part, and they're going to be separated by a multiplication sign. So I see a 3 here. Do I see a 3 in the list of 45? Yes, I do. And how about this 5 over here? Yes, so that means that this one also has a 5. There's a 2, but there's not a 2 here. There's a 2, there's not a 2 here. There's a 3, but there's not a 3 here. So I can go ahead and just write something what they both have in common. So they both have a 3, so I'm going to write a 3 here, just only one, and they both have a 5 here, so I can write 5 here, just only one. And then the GCF says that, okay, well, my GCF is 3 and 5. I'm going to multiply those two, so that's going to give me 15. So my GCF of 60 and 45 is 15. That's my answer, okay? So again, if you can just see it, that's totally fine. But if you're having troubles, go ahead and use the factor trees here. Okay, number 2, 30y cubed and 20y squared. So this time we're dealing with variables, right? So what I'm going to do is I'm going to write 30y cubed and then 20y squared, okay? So now I'm going to look at the 30 and the 20. So let's see, how about 10 and 3? And I can break down the 10, which will give me 5 and 2. And I'm left with all these prime numbers here. For 20 in this case, I'm thinking, okay, 10 and 2, and then 5 and 2. So then I can't break down these numbers anymore. So I'll leave it as that for now. And then this y cubed, that's just going to be y times y times y. And then y squared is going to be y times y. Okay? So I'm going to go ahead and list out my prime factors. So then I'm going to write 5, 2, 3, y, y, and y. And then the other ones, it's just going to be 5, 2, 2, y, and y. So then now I'm going to go ahead and figure out, okay, what is common between the two lists? So I'm trying to figure out my GCF. So I see that, okay, well, here's a 5 here and a 5 here. Here's a 2 here, here's a 2 here. And then let's see, a y here and a y there. I'm gonna go ahead and use a different color here. Let's see, let's use red. Oop, I don't want to do that. I don't want to erase. There's a y and a y here. Okay, so again, I see they both have a 5, so I write only 1 5. I see they both have a 2, so I write 1 2, and I'm separating that, but with a multiplication sign. And then I'm left with a y here. And then I'm going to be left with another y here. And I'm going to go ahead and multiply. So 5 times 2 is 10. And then y times y is y squared. So 10 times y squared is just going to be 10y squared. And this is my GCF. And if we can't tell, well, tell me what number goes into 30 and 20 at the same time. 10, yes? And then the lowest... Or sorry, let me go ahead and just backtrack a little bit. We see that they both carry a y, and then we're going to determine, okay, what is the lowest exponent between the two? Is 2. So that's how I got y squared. Okay, I'm going to go ahead and go a little faster, and instead of doing factor trees, I'm just going to go ahead and tell you, okay, well, what number goes into 20 and 15 at the same time? Well, I'm thinking 5. So I'm going to put 5. That is my GCF, but there's more. I see that they both have x's and they both have y's. So let's write an x and let's write a y here. And then I'm going to ask myself, okay, what is the lowest exponent for the x? Well, we see, if we look at the two x's, the lowest exponent is 2. So I'm going to put a 2 here. And then my y, okay, what is the lowest exponent in this case? 2. So this is my answer. This is my GCF. Okay, now let's take a look at 18, 27, and 81. So what is the GCF? What is the highest number I can think of that goes into 18, 27, and 81? I'm thinking 9. And then I look at the variables. What do they both have? They both have a P and a Q. So I'm going to write P here and a Q there. And then looking at the P's, what is the lowest exponent? So looking at these, the lowest exponent here is 1. And then now looking at the Q's, the lowest exponent here is 2. So I write a 2 here, and this is my GCF. Okay? So now I'm going to go ahead and factor the GCF out of each expression. Okay, so I just want to go ahead and remind y'all what an expression is. An expression is where you have more than one term separated by a sign. Oop, not sign. And there isn't no equal sign, so there's going to be no equal sign, right? So this kind of looks like an equation, right? But this time it doesn't have an equal sign. It's just two terms by itself. So what I'm trying to do is I'm trying to find the GCF. A lot of you would just go ahead and put your answers just like this. but I'm trying to factor. There's a plus sign here, so you need to do something in the form, you know, you have your GCF here, and then you put these parentheses and put stuff in there, and then you put your GCF just as is, right? Okay, so tell me, what is the highest number that goes into 6x and 48 at the same time? Well, I'm thinking 6, so I'm going to put, so again, put the GCF outside and then the parentheses just like so. The GCF is going to go here, so the GCF between 6x and 48 is 6, and then you're not done. It's not just 6. You have to figure out, okay, what goes in here? So 6 times what will give me 6x? That's just going to be x. And then 6 times what is going to give me 48? That's just going to be plus 8. And if you don't know, just do 6 divided by 6. Or sorry, not 6x divided by 6. 6x divided by 6, which is going to give you x, exactly what we have here. And then you're going to do 48 divided by 6. And if you don't know what that is, you just use your calculator. That is going to give you 8, which is exactly what I have there. Okay. The hard part here is just to figure out what is the highest number that goes into 6x and 48 at the same time. And once you get that, you can go ahead and just divide if that helps you. That's totally fine. But again, if you don't know what number goes into this and this at the same time, just go ahead and use those factor trees that we've done before. Okay. Number 6, 12x plus 48x squared. So we need to figure out, okay, well, what do I put here? I'm thinking 12. But they both have an x there. So I'm going to write x. What is the lowest degree? Well, it's just 1. So this is exactly what we have here. Now, I'm going to go ahead and say, okay, 12x times what will give me 12x? And that's just going to be 1. If you don't know that, 12x divided by 12x, that literally is like 5 divided by 5, which is 1, right? And then you're going to say, okay, well, 12x times what will give me 48x squared? And that's just going to be, let's say, 4x, okay? Remember, x times x is x squared. And then 12 times 4 is just 48. So this is my answer. And if you don't know, 48x squared divided by 12x, well, 48 divided by 12 is just 4, and x squared divided by x is the same thing as x squared minus 1, which is just x. Okay. Let's go ahead and do number 7. I'm going to go a little faster. I can see that both of them have, or I'm sorry, the greatest common factor is 5, and the lowest, and they both carry an m, and the lowest exponent is a square. So then I'm left with m cubed minus 5, and this is my answer. Okay, let's go ahead and take a look. I see that they all have x's, but they don't have a y, so I'm going to write 3x, and then get x plus 2y minus, I don't know, 5y squared. Let's see. So 3x times x is 3x squared. 3x times 2y is going to be 6xy. And then 3x times negative 5y squared, that's going to be negative 15xy squared. So this is indeed the answer. Okay. Let's go ahead and do number 9. It says factor each polynomial expressions. If I see if there are 3 terms and in the form ax squared plus bx plus c, where a is 1, then we need to use the x method. So let me show you what I mean. So I have this ax squared plus, no, let's just rewrite this. So this is ax squared, right? There's an x squared and their coefficient is like 1 here. And that's just going to be plus bx, right? This is a is our b, plus c. C is our constant, so that's exactly what we have there. We can go ahead and use the x method. So I draw an x, and then go up top is going to be an A times C, and then B for the bottom. And now I will go ahead and multiply. So I'm going to do 15 times 1, right? Because A times C, I'm only multiplying the coefficients. So 15 times 1 is going to be 15, and then the B for bottom, the coefficient is 8. So I write 8 here, okay? So I need to multiply here and then add there. So I need to use, when I'm looking for these numbers, I need to make sure that these numbers multiply and give me 15, and then those two same numbers are going to add up and give me 8. So my trick is just to take down the 15, or not literally take down the 15, but I'm going to put it down there. I'm going to write, okay, well, give me two numbers that multiply to give rid of that 15. So 5 times 3 is 15, and using those same numbers, 5 plus 3 is 8. So what does this mean? That means that I can use these as our factors. So I need to have my parentheses just like this. And I'm like, okay, well, we know for sure that I'm dealing with the variable x, right? Because here's an x, right? So that I need to put an x and an x here, right? X times x is x squared. After we're folding, x times x is x squared. So x here, x there. And then I'm going to go ahead and just, this is a 5, so I put plus 5 here. And this is a positive 3, so I put a plus 3 there. And this is my answer. Okay. Let's go ahead and do something where you have the second term being negative. There's 3 terms in the form a x squared plus bx plus c. Draw an x, a times c up top, b in the bottom, 6 times 1. So 6 goes on the top, and then a lot of you are going to make this mistake. But when we put b, we need to make sure that we have the coefficient. The coefficient is literally in front of the m, right? So here's our second term, and the coefficient is not 5, it's actually negative 5. So put negative 5 there. Now I'm going to write 6 here, and I'm going to think, okay, well, two numbers I'm multiplying together give me 6, but add up to negative 5. I'm thinking, well, negative 3 times negative 2 is positive 6, right? Because a negative times a negative is a positive. But when I'm using those same numbers, I'm just adding. So this means that negative 3 is 1 and negative 2 is 1. So I'm going to go ahead and write m minus 3 times m minus 2. M times m is m squared, so that checks out. And then I have these, so that works. Okay, let's do number 11. Now this time I'm dealing with my coefficients being, the last two terms here, we have negatives. So draw an x, so a times c above and b in the bottom, and I'm left with, okay, negative 15 times 1, that's just going to be negative 15, and then negative 2 is on the bottom. And, okay, well, what do I do now? Well, I need two numbers that multiply together that give me 15, and those two same numbers are going to give me negative 2. I'm thinking, negative 5 times 3 is going to be negative 15, and using those same numbers, I get negative 2. So let's put negative 5 here, and let's put 3 there. And I'm going to go put p minus 5 times p plus 3. P times p is p squared. That checks out. So this means this is my answer. Okay? All right. So this time, we're going to deal with, there are 3 terms, and a is not 1 this time. So if you have 3 terms, in the form ax squared plus bx plus c, where a is greater than 1, so we can see that this is our a value, and it is greater than 1 because 2 is greater than 1, right? So we need to first check. Your step is to check if there is a GCF. Okay, so let's see if there is a GCF, a greatest common factor, that I can factor out. Well, I'm looking at these, and I can't think of a number that goes into 2 and 5 and also 2 at the same time. So I'm going to go ahead and just do the X method now. So I draw an X, and A times C goes up top, and B goes on the bottom. I'm going to go ahead and say 2 times 2. 2 times 2 is what? 4. And then the B for bottom, which is 5. So I put a 5 here. And then thinking, okay, 4 times 1 is 4, but 4 plus 1 is 5. So I'm going to put a 4 here and a 1 here. And now I'm going to write for my third step is split the middle. Now this is where we use the split method to do the work. So I'm going to erase this so I can see. So what's going to happen is I'm going to keep this in this, but split using that, right? 4 plus 4x, so pretend that there's an x here and an x here, okay? 4x plus 1x is going to give me 5x. So I'm writing 2x squared plus 4x plus 1x, right? We see that 4x plus 1x is 5x. I'm just splitting that up, plus 2. Okay, let's write this. Since there are 4 terms created, there are 4 terms we group. So then I put these parentheses here. We're grouping. We're going to go ahead and find the GCF after we group. And then I'm going to be like, okay, well, maybe I should use different colors here, so we can see what's going on. Okay. I need a number that goes into 2x squared plus 4x. Well, I'm thinking, okay, 2, and then they both carry an x, so I put a 2x there. Okay, now I'm going to go ahead and say 2x times what will give me 2x squared. We're going to say that that's just x, and then 2x times something will give me 4x, so that's just going to be plus 2. Now we're going to go ahead and look at these. I'm like, okay, what number goes into 1x and 2 at the same time? And I'm thinking just 1. Okay, and then it's just going to be x plus 2 here, because 1 times x is just 1x, and 1 times 2 is just 2. Oh, that's not what I want to do. Okay. Now, we're going to find the GCF again. So I see, what do these 2 groups carry? Oh, I forgot to put a plus sign here. There should be a plus sign there. Okay, what do these 2 carry? Well, they both have an x plus 2. So I'm going to write x plus 2 here, and then I'm like, okay, let's put these parentheses again, and it'll be like x plus 2 times what will give me 2x times the quantity x plus 2. Well, this is all multiplication. 2x times x plus 2, right? So if 2x times x plus 2 is this, then x plus 2 times 2x is going to give me for sure that, yes? So let's put 2x there, and then 1 times x plus 2. Well, x plus 2 times 1 will give me this, so I'm just going to put a 1 here. And then this is what I need. That's my answer. It's a lot of steps, but this is good. Let's go ahead and do that again. So this is going to be negative 4 times 4. That's going to be negative 16. And then this is a negative 6, okay? Oh, wait. I should not do that first, because what I want to do is what? Step 1 says check if there is a GCF. So is there a GCF? Well, what number goes into 4n squared minus 6n minus 4 at the same time? Well, I'm thinking just 2. So I write a 2 here. And that's just going to be 2n squared minus 3n minus 2. And then since I'm going to, this right here is just exactly what we have over here. Well, not really exactly, but in the same format. So I'm going to go ahead and split that up using the x method. So I'm going to go -2 times 2. It's just going to be -4. And then put in the bottom, that's going to be -3. So I'm thinking, okay, well, two numbers that multiply together to give me -4. Well, I'm thinking -4 times 1, because that's -4, and -4 plus 1, that's going to give me -3. So -4 goes here, and -3 goes there. Oh, not -3, +1. There you go. So then what's going to happen to this 2, right? I factor that out. We can't neglect it, so let's just put 2 here. And I think I'm supposed to put the parentheses like this. Okay, let's put x minus 4, or not x minus 4, n minus 4 here. Oh, no. Sorry. Remember, we're trying to split, right? Our next step is, after we do the x method, we need to split the middle method. So I write 4n squared minus 4n plus 1n minus 4. Okay? And I'm going to go ahead and change these two brackets instead. And then I'm going to go ahead and group them up. So then I'm left with 2. And I need to figure out, okay, what is the GCF here? Well, it's just going to be 4n. So I'm left with n minus 1. And then what's the GCF here? Well, that's just going to be... what did I do? I think I made a mistake somewhere. Oh, that's strange. I don't know why I put a 2 here. Oh. And I don't know why I put a 3 in here. Or, okay, there's supposed to be a 3 in there. And then... No. I don't know what's going on. Okay, let's try to start over. Oops, my bad. So I write 2 here. And then I write 2n squared minus 4n plus 1n minus 2. Yeah, that's right. I'm going to change these two brackets. I'm going to go ahead and group these. And then, let's see, 2. This is going to give me, okay, so I'm left with 2n here. So that's going to be n minus 2. Okay, there we go. I just made a mistake. And then a 1 goes here because the highest number that goes into 1n and minus 2, or my Gcf that goes into these two, is just 1. So I put n minus 2 there. And then I see something in common. So I write 2 n minus 2 times, let's see, 2n plus 1. There should be a plus there. And that's it. I think I should just get rid of the brackets here. This is my answer. Okay? Alrighty. So, first, is there a GCF? No. So I'm going to go ahead and multiply. And then, thinking the numbers, I'm left, let's see, 15 and 4. 15 times 4 is 60. 15 plus 4 is 19. So I write 5n squared plus 15n plus 4n plus 12. And I'm going to split. So then I have, let's see, 5n squared plus 3. Actually, no, I should put an n here. N plus 3. Yes, that's right. And then I'm left with as my answer. Okay? Alright, factor each difference of squares. So, difference of two squares when you have two terms that are both squares and there's a minus sign in between, you want to go ahead and just remember the format. If you have something like a squared minus b squared, that's just the same thing as a minus b times a plus b, right? So going ahead and look at number 15, I can, these are both squares, right? When I say m squared minus 64, and 64 is a squared because 8 times 8 is 64, you need the same number that multiplied together to give you this number, right? Taking the square root of 64 is going to give you a perfect number, which is 8. Taking the square root of 36 is going to give you the perfect number, which is going to be 6. So looking at this, number 15, okay, well, all I know is I'm dealing with an m here. So I have, an m here and an m here. And because I know that m times m is m squared. And then now I'm going to put a plus sign here. One for happy and one for sad. And then, okay, what times what will give me 64? Well, 8 times 8 is going to be 64. And 8 squared is 64, right? That is what you call a square. So, that does not look like a good 8. So, there you go. This is my answer. Number 16, again. Something times something is going to give me 36. Take the square root of 36. That is just going to be 6, right? So put a 6 here. Minus. And then what times what will give me 9. So 3, if I take the square root of 9, that's just going to be 3. And then d times d is just d squared. That's my answer. Okay, 25 minus 4d squared, that's just going to be 5 plus 2d, and then 5 minus 2d. And that's my answer. And then this one is dealing with, this one is weird because this has a 4, but that's okay. We can just go ahead and do, okay, what times what is going to give me 81? That's 9. What times what is going to give me c to the 4th power? C squared, put a plus sign and a minus sign. Something times something is going to give me 16, which is 4 and 4. Am I done? No, because I can still take the difference of 2 squares here, but not this, okay? But this is going to be part of our answer. So I know for sure that I can take the square root of 9, which is 3. I can go ahead and take the square root of c squared, which is just c. And I can go ahead and take the square root of 4, which is just 4. And remember, you have to put a plus sign here, and you're going to do the same thing on the other side as well. So this, if you include this, is your answer. Okay? Alrighty. Number 19, it says factor each expression by grouping. Okay, we've done grouping before. So I'm going to put those parentheses, and when you see that negative, make sure that negative is inside the parentheses, but if there's a plus here, it doesn't do anything, but that negative is going to be very, very important as we factor things out. Okay, so now I'm like, okay, something here is my GCF. What is the GCF of 12x cubed and 2x squared at the same time? Well, I'm thinking, okay, 2 goes in there, and then they both have an x, so I put an x there, and then the lowest exponent is the 2nd power. And then what do I put here? Well, 2x squared times something is going to give me 12x squared, so that's going to be 6x. And then 2x squared times something is going to give me positive 2x squared. Well, that's just itself. So, 2x squared plus times 1 is going to give you 2x squared. So plus 1 goes right there. Okay. And then next, I need a GCF here and then deal with things. So when I have a, remember, when I have a group and it starts with a negative, I need to factor that negative out. So that negative is going to go here, and then the number that goes into 30x and negative 5 at the same time is just 5. They both don't have an x, so I don't put an x there. And then negative 5 times something is going to give me 30x. So that's just going to be 6x here. And then negative 5 times something is going to give me negative 5, and that's just going to be positive 1, right? Negative 5 times 1 is just negative 5. And what do they have in common? 6x plus 1, right? So I'm going to go ahead and put 6x plus 1, and then 2x squared minus 5. Okay, where did I get this 2x squared minus 5? 2x goes here, minus 5 goes here. Okay. Take a look at this one. Put those parentheses. Now remember, I don't care if there's a plus sign. It doesn't matter. Oh, let me go ahead and just tell you that if you have 4 terms, you got to make sure that you group. I think I should have said that at the beginning, but yeah. Okay, let's go ahead and do this. Okay, what is the GCF that goes into x cubed and to x squared at the same time? That's going to be x squared. X squared times x cubed is going to be x, and then x squared times what will give me x squared? That's just going to be positive 1. Okay, now the GCF that goes into 2x and 2 at the same time, that's just 2. So 2 times what will give me 2x? That's just going to be x. And then you can just see that, okay, well, there's an x plus 1 here. I'm pretty sure it's just going to be x plus 1. But you got to make sure that you verify that, okay? So as we factor things out, this is your answer, right? I put the common stuff over here. Actually, let's just do this. And then what's left? X squared, 2, and 2. Okay? Ooh, this one's a little weird, but that's okay. Let's go ahead and put those parentheses around. And there's a negative sign here on my last 2 terms, so include the negative inside the parentheses, please. All right. This is what I'm doing. Every time I see 4 terms, this is what I'm going to be doing. I'm put those parentheses, and then I'm going to figure out my GCF, put parentheses, GCF, put those parentheses, okay? So what goes into 4x squared plus 6 at the same time? I'm thinking 2. And then what goes into negative x and negative 24 at the same time? I'm thinking just negative 1. Right? And this one's a little weird, but okay, well, 2 times something is going to give me 4xy. So let's put 2xy here. And 2 times what will give me 6? So that's just going to be positive 3. Look on the right side, negative 1 times what will give me x? That's just going to be x. And negative 1 times what will give me negative 24y? That's just going to be positive 24y. And I don't see anything in common here. So my answer is not factorable. Not factorable. Okay, so now let's go ahead and move on to factor each expression completely. So most likely on the test, you won't be told what you have to do. You're going to have to figure it out. So honestly, if I were you, just look at some problems, do more practice, and then you'll see you'll get natural at this. So 22, let's take a look at this. 8y to the 4th power plus 32y cubed plus 24y squared. Notice that I only have 3 terms here, and it is not in the form ax squared plus by plus c, unless we can do that. Let me think. I think we can do that. All right, let's first of all, there are 3 terms. Let's go ahead and factor things. We want to see it first. Let's see what number goes into 8y to the 4th power plus 32y cubed plus 24y squared. I'm just thinking 8 goes here, and then I notice that everything has a y, so put a y there. What's the lowest exponent? It's a 2, so 8y squared. And I'm going to go ahead and just say, okay, well, 8y squared times what will give me 8y to the 4th power? I'm thinking y squared here. 8y squared times what will give me 32y cubed. Well, that's just going to be plus 4y. And then next, I'm left with, okay, 8y squared times what will give me 24y squared. And that's just going to be positive 3. Okay. Okay, now this is where, okay, yeah, now I see it. So again, you factor the expression completely, but are you actually done? You need to look at this and be like, okay, I see an ax squared plus by plus c. That means I got to keep on factoring. And what does that mean when I have, you know, ax squared plus by plus c, where a is only 1? Well, that means you got to use the x method, right? So let's do it. X here, so 3 times what will give me, 3 times 1 will give me 3, so I put a 3 there, and then I put a positive 4 here, so that just goes there. So that means that 3 and 1 goes there, so I'm left with ay squared times y plus 3 times y plus 1. This is my answer. Okay. One thing I always want to do is always find if there's a GCF. Okay, if I see 3 terms in the form ax squared plus by plus c, check if there's a GCF. So I think 2 is appropriate, right? And I put a 2 here, so I'm like 5x squared minus 8x minus 4. And it's not going to give me that a equals 1 here, because a is actually greater than 1. It's 5. So we need to do the split method. So I'm left with negative 20 and negative 8. So negative 5 and negative... no, let's not do that. Let's do negative 10 and 2. And I write 2, and I write 5x squared, and we're going to split the middle. So that's going to be negative 10x plus 2x minus 4. And then I group them. Just like that. I'm going to keep that 2. Remember, that 2 is outside. Don't neglect it. So we group. So what number goes into 5x squared minus 10x at the same time? 5x. So this is going to be x minus 2. And then what number goes into 2x minus negative 4? Or sorry, minus 4. That's just going to be 2. So that's just going to be x minus 2 there. So then I'm left with 2 times x minus 2, 5x plus 2. And this is my answer. Okay. Now, if you skipped parts, if you managed to, skip to this part of the video without watching the other stuff, I would recommend that you go find the part where I slowed down and explain what I was doing. Now, right now, I'm just going a little faster because it's already repetitive at this point. I don't want to go and just repeat myself over and over. So I'm just going through the problems really, really quickly here because we've already done problems like these before. Okay. Here I see that I have 3 terms in the form ax squared plus bx plus c. Can I find a GCF? No. But I can go ahead and start doing the split method. So I have 21 times 2, which is just, 42? And then I put a 17 here. Now I'm thinking, okay, well, give me them 2 numbers here. Let's see. Maybe can't be 6 and 7. Sometimes this might take me a little while to figure out. Can I do, let's see, 42 divided by 6. Sorry, I'm getting my calculator out, trying to figure this out. 42 divided by 6. 6 plus 7 is 13, so that's not what I want. But let's see. Okay, I got it. 14 and 3. Because 14 times 3 is going to give you 42. So then I write 2b squared plus 14b plus 3b plus 21. Remember, 14b plus 3b is going to give you 17b. That's right. So let's go ahead and group. And you're left with 2b times b plus 7. And then here you put plus 3b plus 7 here. You factored one more time. This is your answer. Okay? Let's go ahead and take a look at 25. My goodness, there's so many problems here, but this is good practice. Okay, so let's take a look at 25. I want to make sure that I can find the GCF of things. So what am I thinking? Maybe, maybe a 4. Let's see. They all have an n. So let's try 4, and my lowest exponent is an n squared. Okay, so 4n squared times what will give me 28. 7n squared plus 4n minus 20. Yes, there you go. And am I done? Okay, am I done? No, I need to make sure, because I gotta factor this. Let me see if I can do the x method with this. So I'm negative 140, right? And I'm left with 4 here. So now I'm thinking, okay, well, what are the numbers that you know, multiply together, give me negative 140 and add up to 4? Can I do this? I have no idea. I can't. I'm trying to think. Can do 10 and 4, but that'll give me 6. So that's not right. I'm going to have to use a calculator again. 140 divided by 12. No, 140 divided by... I might have to skip this problem for now, because I can't think of something here. Yeah, I'm probably going to have to skip this problem. Yeah. Skip this problem for now. I can't figure out something. Okay. Let's see. I have 4 terms here. Did I have 4 terms? No, I have 3 terms. Okay, so I have 4 terms here. So I can go ahead and use the grouping method. And I'm thinking, okay, well, it looks like 15 goes into 105. Does it go into 175? It does not. So let me think. I know 5 goes into 175. But let's see. Is 105 divided by 35? Yes. And what about 175 divided by 35? Yes. Okay, so I'm going to do 35n squared times, well, 3n here and a 5n, no, just 5 here. And then the negative is in front of this group. So I'm thinking, let's see, what do I put here? 25, yes, I put 25, so I put negative 25 there, and I have 3n plus 5. There you go. So I'm left with 35n squared minus 25 times 3n plus 5. And that's my answer. And now I'm going to go look at number 27. Is there a number that goes into 10, 89, and 9 at the same time? I don't think so. But I see that I can factor an m, though. So let's do 10m squared plus m minus 9. And then I have a 90 here and a 1 there. So how about... Is this going to work out? Oh, I'm sorry. I'm supposed to put an 89 there. Yeah, let's put an 89. M. So then this is going to give me 90 times 1, or negative 1. So m times 10m squared plus 90m minus 1m minus 9. And I'm going to go ahead and group these. So I'm left with, okay, so I put an m here, and I put 10 there, 10m actually, and I'm left with m plus 9, and then minus 1 goes here, and then it's going to be m plus 9 there. So then I'm just going to put 10m minus 1, m plus 9 there, okay? I'm not sure what 25 is. I'm probably going to have to skip it and say, whatever, you don't have to do that problem, because I can't think of something. Maybe this is an error or if you want to correct me, that's totally fine, and I can update the key. But I'm going to go ahead and move on. We use the X or the AC method when we have 3 terms. We factor by grouping when we have 4 terms. When terms have something in common, we factor by the GCF. Right? A squared minus b squared is equal to a minus b the quantity. A plus b the quantity is known as factoring a difference of 2 squares. Okay? Alright. Geometric problem. More factoring, but this time we're going to apply it in the context of, geometry. The area of a rectangle is a squared minus 13x plus 42 feet squared. The width is x minus 6 feet. What is the length of the rectangle? Okay, so let's go ahead and draw a rectangle. And we know that the width is x minus 6, and the length is something that we don't know, right? Remember, the area of a rectangle is length times width, and we know what the area is because that's already given. Every time something is already given, I'm going to replace that word area with the given expression. So this is that. So I write x squared minus 13x plus 42. I don't know what the length is, but I do know what the width is. So I write length, and then I put x minus 6. It's the same thing as multiplication. So then what do we have now? Well, I have this. We know we know what to do there because we see 3 terms in the form ax squared plus bx plus c. So I write 42 here, negative 13 there, and I'm thinking, okay, negative 6 and negative 7. So as I factor those, I have x minus 6 times x minus 7 is equal to my length times x minus 6. I'm trying to solve for this variable, right? This is the same thing. Again, this is the same thing as saying L times x minus 6. It's like saying 5 times w or whatever, right? This is my 5, that's my w. Just pretend that there is. And what do I do if I'm trying to solve for w, right? I got to divide both sides by 5. And here, I need to divide both sides by x minus 6 because I'm trying to figure out what the L is. Now, notice this. What can I cancel out? What do they have? What do they both have in common in terms of, here's this is the bottom, here's the top. What do they both have in common that I can cross out? Well, there's an x minus 6, so I can cross that out. And I'm left with x minus 7 is equal to my length. So my answer is this. Okay. What do I have here? The area of the square is x squared minus 14x minus 49. How long is each side of the square? So we need to know what the definition of the square is, or I can just draw a picture. So I'm going to draw a square here. And notice that a square, they all have congruent sides. They all have the same, sides here. So this is 5, that's 5, that's 5, and that's 5. And, it's just a box with the same, the side lengths, right? So we need to make sure that we apply that context, apply that, that definition and knowledge to what we're going to be doing now. This right here it has nothing to do with the problem. I'm just demonstrating what the definition of a square is. So we know the area of the square is x squared minus 14, x minus 49. How long is each square? So remember, A is equal to length times width, because that's the formula, or that's the area of a square formula. And then I see that there's three terms in the form ax squared plus bx plus c. So I write negative 49 and negative 14 here, so for sure that's just going to be negative 7 and negative 7. No. Negative 14, negative 14x. Is it not positive? Let me see. 1 second. I think I just got thrown off a little bit. I would say negative 7 times negative 7 is going to give me negative 14, but negative 49? Negative 7 times negative 7 is going to be positive 49, so that's not right. Let me think. 49 divided by 3, 49 divided by 6, 49 divided by 7, 49 divided by 12, no, that's not right. 49 divided by 13, let's try 13. No, 49 divided by 16. 49 divided by 17. I think there's a typo here. Okay, so I'm pretty sure it's supposed to be a positive 19, not a negative 19. Okay, so that's just going to be negative 7 and negative 7 here. So you should have A is equal to x minus 7, x minus 7. And, x minus 7, this is my length, and this is my width. And how long is each side? Well, it's the same side, so it's just going to be x minus 7, which is your answer. Okay, there you go. Let's go ahead and do number 30. For what values of b is the expression x squared plus bx plus 24 factorable? So remember, we multiply this and we add to get that, right? Because when we're doing the x method, the b is in the bottom, the 24 goes at the top. So let's put 24 here and think of, okay, two numbers. I'm thinking 2 times 12. And what else do we have? 4 and 6. 6, 12, 18, 24. That's good. What else do I have? 8 and 3. I should have put that up top, but that's totally fine. And then what's next? Do I have 24 and 1? Okay, there we go. So then when we multiply, we got to make sure that we add those two numbers. 2 plus 12 is just 14. So this is my b value. And then 4 plus 6, that's 10. So that can be my b value. 8 plus 3, that's going to be 11. That can be my b value. And then 24 plus 1, that's 25, and that can be my b value. So these right here, these can be my b that will make the expression factorable. Okay. Name 4 values of b which makes the expression x squared minus 3x plus b factorable. So let me go ahead and just, I'm gonna go back to, I was trying to make a key, but let's see, where is it? This right here. What can make my b factorable? So what I did was, this, when we're adding, right, when you're adding, we did negative 10 plus 7, that's going to give me negative 3. Negative 5 plus 2, that's going to give me negative 3. So that means my b can be, if I multiply, negative 10 times 7 is negative 70, and then negative 5 times 2 is just what? Negative 10. So yes, these can make my b, you know, factorable here. All right, here we go. Let's go ahead, and I'm going to take a break, and I will come back and do the remaining problems with y'all later.